Hello and welcome to today's webinar from Zero Day to Hero. I'm Jacob Lukowitz, Multimedia Editor of SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website about 24 hours after the event. Secondly, if at any time you have questions about or during the presentation, you may submit them using the chat. In today's webinar, we'll get updated on zero-day vulnerabilities and see how Contrast Protect adds critical application hardening to avoid potential disasters. Joining us today are Naomi Buckwalter, Director of Product Security at Contrast Security, and Sam Levin, Sales Engineer at Contrast Security, who will be going over the demo. Great to have you guys here.
All right. Welcome, everyone. Thank you so much for joining us on this webinar and listening in on this. I know you guys have tons of things to do, so thank you so much for spending time with us, the wonderful folks at Contrast. Today, we're going to be talking about Contrast Protect, one of our core products, part of our Contrast Protect suite. And I am here along with Sam Levin, one of our wonderful sales engineers, to talk about how Protect might actually help you and your company. So I know you as a developer, engineer, CTO, you are yourself a person who is interested in building awesome things, but in order to build awesome things, you want to be sure that they are protected and that they are secure from attack. So let me just show you this image real quick. What do you see here? Trick question, it's not that difficult. It is a neighborhood, a bunch of houses. And I wanted you to take a look at this because when we talk about applications, you're really just building a house, are you not? You're building things that do things, like in this case, a house where you keep a family safe and protected and alive and out of the elements. You are protecting your company's data, for example, or you are protecting your family within the company itself. Your application is there to keep everyone safe. And sometimes your applications in your houses have a way for the public to interact with it, like a mailbox or anything else like this. And the street here can represent the internet, because anyone can drive down your street. If you have a neighborhood that's open to the public, you're not gated community, anyone can drive down with their car down to your street, and literally anyone can walk up to your driveway, walk up to your front door. And that is how it's true also, is it not, for applications? So if you have an application on the internet, you have a front door, say a login page, or you have a driveway that people can just walk up to and take a look at your house, and you want to make sure that house stays protected. So I want to come back to this house analogy because I think it would make a lot more sense once we start talking about Protect. But think about your application as maybe one of many houses. You have multiple houses that you've built. You're just trying to protect the things inside it, like your furniture and all your memories and all your family and your data, essentially. So when we talk about applications, we are also talking about vulnerabilities, because everyone knows that the more time you've spent building an application and the more hands on the keyboard that you have building the application, the more vulnerabilities are actually going to be introduced into that application. New vulnerabilities are shipped to prod every day. In fact, there was a study done about 15 bugs per 1,000 lines of code. Yes, 15 bugs per 1,000 lines of code make it out to production. So the customers are actually interacting with 15 bugs per every 1,000 lines of code. That's a lot. Source being CoralLogix did a study back in 2021, I believe. And this is another one, a stream of 0 days from our friends over at Google. They actually discovered that there were 18 0 days in the first half of 2022 alone. And that is quite a lot. They haven't even done the full study for this year yet, 2022. But in last year, they did the same study, 58 in 2021. So what we're trying to say is there are plenty of 0 day vulnerabilities still hounding us as developers and people trying to build awesome things for our customers. And we are trying to protect what we're building. But we know that the more time that goes by and the more hands on the keyboard that are touching our applications, the more chance and the likelihood is more vulnerabilities being introduced into our applications. Not only that, but all those 0 days coming out, the things that we don't even know about that might exist. So sometimes we do create applications and we knowingly put out vulnerabilities because sometimes we don't have enough time or the resources to actually patch for them or fix them, or they're just not severe enough to warrant any kind of immediate reaction. You're like, okay, we're going to throw in a WAF, or we're going to put up different mitigation strategies to mitigate the risk for this vulnerability. And that's totally fine. That's up to the business. But in some cases for 0 days, you didn't even know that vulnerability was out there. And that's what makes it so dangerous. So in this case, for a house, you didn't know that the crack in your window that every house has on the street, everyone's using the same builder and the same manufacturer and therefore the same Windows, has that same vulnerability. Like if you played a certain frequency on your radio, it would crack, right? Like that would be an awful vulnerability to have. It's something that's very similar to a 0-day. And we certainly saw that with things like Log4j and Spring4Shell last year. If we take a look at some of the traditional remediation strategies in the past, what we can tell you here, at least that we've seen, is the traditional paths really are untrustworthy. We've put too much trust in our people, to do the right things, to code the right way, to have the threat modeling exercises, to do security reviews and code reviews. And we know that we just don't have all the people and all the time in order to do this. And yes, they want to do these things, but competing priorities and different issues pop up during the day, and they just don't have the time. They want to do these things, trust me, but they just don't have the time. And so we sometimes put in things like a WAF, a web application firewall. And we say, okay, if people can't determine what all our vulnerabilities are, we're going to at least have a WAF in place. But we know that WAFs aren't bulletproof either. If you're going to have internet traffic coming into your web applications, there's going to be a certain amount of web traffic that needs to flow through that might contain, exploit code within the actual parameter query. Like there's going to be things that go through your WAF and you won't be able to stop them because your firewall rules are imperfect. And we do this purposely because we want to allow all legitimate traffic to go through to our applications. We don't want to block legitimate traffic. That means we'd be blocking business from happening in our organization. We want all legitimate traffic to get through. Therefore, some illegitimate traffic might get through. And this is why web application firewalls are imperfect. And so back to this house analogy, this is one of our favorite holiday movies. If you're home by yourself, I would say, like, if you're thinking about this, Contrast Protect would be the little boy in this picture here trying to protect their house, their application. And what Protect will actually do is, instead of modifying the house, we don't modify any code within your application. What Protect will actually do is it will set traps, little traps within the house itself. So if an attacker were to get through, we'll see this funny man in the hat here and staring through the window. He's trying to get through to this boy that's home by himself. The attacker is trying to get through. And so Contrast Protect will set like the marbles and the fire thing. And the attacker is going to have the hardest time trying to get in. And Protect is awesome that way, because instead of changing anything within your house, it's actually going to stop the attacker from getting any further inside the house, and they won't be able to steal money off the counter, for example, or look inside your jewelry box, because Protect has created these traps and also an ability to sense things within the house. So think about like any IoT devices that's currently on the market for smart homes. You've got your temperature readers and motion detectors and things like that. Protect is essentially doing that. We're adding instrumentation within the house that actually says when an attacker is trying to do something bad. If an attacker got inside the house, we have a motion detector for that. Or there's like the heat went up, the ambient heat went up within the certain room. Well, we know somebody's in there because, right? So there's these things that Protect can do. We add instrumentation and we set those traps, because once the attacker gets in, and I'm going to tell you this, attackers do get into your house, we want to be able to stop them from leaving with anything bad or doing anything damaging within your house. And that's what Protect will do. So think about it again as an analogy. You are building a house and you're trying to protect the things within the house. Protect is here to help you do that, add in defense in depth for your actual house. So I will turn it over to Sam. He's going to show us a little bit of a demo on actually how Protect is installed and how it works. And I believe that is here.
Yeah, so picking up where Naomi left off, right? This analogy of being able to mitigate against the exploitation of vulnerabilities that make their way into production, right? How is this accomplished, right? This is obviously a great benefit, right? You may not know about all the vulnerabilities in your custom code, or you may not know about a vulnerability coming out in a third-party library tomorrow. But we want to make sure that you have that breathing room to prevent that code from being executed and exploited. And so this slide here will talk about how we accomplish this, right? So in the scenario for a Java application, Contrast can support a wide range of web applications different languages. But for Java, right, the contrast agent is actually a jar file that can be installed onto, say, a Tomcat server or even a container, right? So when that Java agent is part of the running web application, the JVM allows the Java agent that we're providing, right, contrast, to instrument the full stack of the application code. And that's what you're seeing here. So those little green dots are representing the idea of all the little sensors or, and the other analogy traps, right? It does not rewrite code, but it allows the insight for the agent to see what code is being executed. So, and this means that once we can see with contrast, like the contrast agent, once it can see the code being executed, it can detect when code is going to behave in a way that is, exploitable, right? In a pre-production environment, this allows us to do something called IAST, right? Interactive Application Security Testing, to find vulnerabilities. But in production, right, this is what we're talking about today, this allows us to block the vulnerabilities from being actually exploited when a payload is sent in. So on the far right, you also see that the way that even a user would understand what's happening inside their applications is a dashboard. So the agent instruments the application stack. It can then determine when there is going to be a payload that could hit a exploitable line of code, and it's informing a dashboard about what's going on, just by sending out telemetry. Again, yeah, this isn't rewriting the code, but it is, again, sensing through instrumentation, such as the API for instrumentation that Java even provides. We can go to the next line. All right, picking up. Ready? Here we go. So again, what does it look like as that payload I described is moving through the application? And also talking about how Naomi described this as essentially defense in depth, right? Here you can see a WAF is represented in this diagram. A WAF is great for dealing with network level issues, such as distributed denial of service attacks, but it is not going to be great at determining, sort of advanced attacks that can bypass a WAF, and it can be fairly trivial for an advanced attacker to bypass a WAF. So an attack event is something like, let's say, in this diagram here, a SQL injection attack, right? The contrast agent is going to be able to see that a user payload, right, contains some data, and that data might go through that web request, but then it might get through some validation tags, and it might go through some additional business logic, maybe pass from a function, and eventually get passed to an actual query statement being generated. At that point, the contrast agent can see through this system of checks that, hey, the semantics of this query statement are changing based on this initial attack event, which carries a payload, right? It's going to actually change this query statement. It's going to execute arbitrary SQL commands. And at that point, contrast agent is able to throw a security exception, halting the execution of code there. Again, it doesn't crash the application, but it throws an exception that an application can handle, just as it would, say, a 404 or something like this, right? So your exception handlers are seeing that this next line of code is not going to be executed where the vulnerability is. And this is obviously, going back to what we talked about before, a great mitigation effect for production, while your dev teams have time to then go about actually making the remediation. How this is going to look in real time with contrast, protecting an application, and for the scenario we just talked about on the slide, SQL injection specifically. So here we're looking at our contrast dashboard, and I'm going to navigate in our application inventory to a specific Java application that we can demonstrate how to block attacks. So this is a purposely vulnerable application, but it's going to be great to demonstrate, how we can then prevent an attack, but also, actually what it looks like if it was exploited. So here, Pet Clinic is in various development phases, such as development, QA, and production. And you'll notice that inside of Contrast, the same agent that is installed in different locations can be toggled to either be working on assess, finding custom code vulnerabilities in pre-production or QA, or being able to set to protect in a production environment. And it operates differently because in production you have different needs versus the needs that you have in development. So let's navigate over here to our production server. This is a piece of functionality that can look up a user based on their last name. So we're going to enter in a web request containing some data, and it's going to, of course, try to query the database and then represent that data back on screen. So first, let's show you that this operates as normal. Of course, I can look up any user. I know there's some users named Davis, and they show up just normal. But again, let's see what happens if we put in some SQL statements. Let's see what happens, what goes on here. This is recognized as SQL injection, and it is blocked. In this demo environment, we're going to be able to have like a nice little handler page, but in a real life environment, essentially you can have that security exception be handled as not resolving the page at all or sending them back to the home page. Without protect mode on, that same sort of injection would have resulted in something like this, the full database being sent back to an attacker, right? So exposing the contents of the database. So let's check out what's going on Contrast side to show exactly what an attack event looks like. So let's go check into the 14 attacks. I've been launching attacks on this application quite often. This is one that was sent 2 hours ago, but it takes about a couple seconds for us to log new attack events, but this is the same attack. Oh, here it is right here, the one from just a minute ago. So as we get attack events logged into Contrast, we can show them here. And of course, we can have integrations with things like Splunk, so that the application security team or the security operations center can see what's going on with their applications. Like, are people sending payloads at us? Are they being blocked? Are they being exploited? Opening this up, we'll be able to see exactly why Contrast determined that this was something that needed to actually block. So again, we can see the application was that Pet Clinic app. The rule that we detected being violated was SQL injection, and here's even the payload. So again, something that I think even a WAF can see is obviously what was the URL parameters, right? What was the web request? But the power of Contrast is that it's working within the application code, right? And we can see here that this query statement, as it was being formed, was taking in those arbitrary SQL statements, right? This is why altering the meaning of that query statement indicated that we should block this line of code, this next line of code, from being executed. We look into our details page. Of course, we can also provide what's happening in the stack trace, right? Where was the issue occurring? Why is this actually vulnerable? Something else I'll highlight within Contrast Protect is that this is a vulnerability that does indeed exist, and we blocked it. But if we were to look at just all attack event types, you can see here that if a particular attack is probing, right, there's like attack payloads coming in, but they're not actually hitting anything, we'll register that attack event as well. So as people are throwing payloads at your web applications, we are able to show that too. Another really important part of using Protect is being able to understand that it doesn't care about CVE signatures, right? Like if we're able to block against things like Spring for Shell or Log4j or any number of other potential CVEs. It's not that we're blocking against the CVE, is that Contrast is blocking against the vulnerability method or the vulnerability type that is being leveraged, right? So you can see here that with class loader manipulation, that's one of the key vulnerabilities that Spring for Shell actually tries to exploit. So if we recognize the behavior of the application exhibiting that class loader manipulation is going to occur, we're blocking against that. We don't care that a new CVE comes out tomorrow. We're already protecting our customers today. In fact, if you take the oldest agent that we have available, like an artifact that you can download, an old agent, right? That agent from years ago was able to prevent Log4j from even being exploited because we had things like expression language injection protection, right? We had JNDI injection protection, right? These were important elements of those CVEs and how they were able to give an exploit out to then take advantage of these types of vulnerabilities. So this is something really important and powerful for people to understand, is that it's, again, because the agent is operating and seeing the execution of code at runtime that we can prevent and verify through behavioral analysis that these vulnerabilities exist, and then throw those security exceptions, thus saving you, from being exploited in production. This is critical so that people don't have to run around after hours trying to fix things, right? They know that they're mitigating these attacks, buying them time to then get the remediation put in place. So we just talked about how we could prevent something common, right, like SQL injection from being exploited. But again, how about something a little bit more novel, like class loader manipulation, which was seen with Spring for Shell? So on screen here is a little Spring for Shell demo application, which is vulnerable to class loader manipulation. And I'm going to show exactly how we're able to exploit that, and then how Protect can then block that. It's not as flashy because it's not a full developed application, but clicking in over here, you can see that I have this very, very simple application running, right? So it's just, we have this one little page hosted, but the page I want to draw your attention to is this page, right? This page does not exist, right? There's nothing here. But through class loader manipulation and the publicly available exploit that came about when Spring for Shell was announced, we can open a backdoor to this web server and then write something to this page, right? So let's show that. Again, if we look over here at our server, you can see that on my demo server right here, we have Protect off. So we'll actually exploit this first. So this is our application running just fine over here, but this is what the attacker sees, right? It's always green and black. So right here, I have a little Python script that, when targeting this this page here, should actually create that backdoor and allow us to write arbitrary commands to this web server. So I've executed it here. Again, you can see that this right here, this page doesn't exist, but if we refresh it, we have now written to this page, unauthorized, totally, like, this is remote code execution, right? So let's jump back over to our Spring for Shell demo app inside of the view of Contrast, right? We do have IAST running on it as well, so we can show you the idea of course, we are picking up command injection just as a vulnerability being reported in here. But right now, we don't have Contrast turned on, as I demonstrated earlier. So let's turn that on, and then let's launch the attack again to show you us, and Contrast's ability to block this attack. So we're turning contrast back on. We're going to cycle this server. So we've cycled the server, and you can see again from a fresh state, this page does not exist. The application is up and running again, right? This page that we previously wrote to and with the command injection with manipulating with exploiting class loader manipulation does not exist. If we launch this attack again with protect, right? Attack launched again, this page doesn't exist, right? We haven't been able to do remote code execution to this server. We jump back into the contrast dashboard and we look at this application and we start investigating what new attacks come through. Let's check that out. So we've refreshed the page and now we're seeing here that that new attack came through. We logged it from a minute ago. Let's click into it to show exactly what was going on. You can see here specifically on the attack, right? It was doing class loader manipulation. We can see that that was occurring, right? We did block it, and we can even investigate exactly the details here. So again, this is another really important part of contrast. It's quite powerful, from anything from the common OWASP top 10 to even things that are being leveraged in CVEs coming out today, like even just this past year with Spring for Shell.
So thank you both for a great presentation and demo. I think there was a lot of great insight there for the audience with the hands-on approach. So one question I have is, how can people learn more and get in contact with you?
Yeah, definitely. So thanks again for being able to allow us to have this platform to share out what we're doing and where we're innovating. Here, I'll share my screen real quick. So from here, Contrast has the, oh, it's just popped on. Yeah, so from here, yeah, like our community edition is open for people to sign up to. It contains the full platform. You're able to add just one of your own sort of trial applications to give it a shot. But being able to go down here and sign up for a community edition account will allow us to get in touch with you to see how you're interested, and also trial protect yourself in one of our with one of our test applications. So I think that would be a great place for people to get started, and then of course also from there we can always organize a demo privately for anyone who's interested.
All right, great. Thank you again. That was Naomi and Sam with the presentation. And thank you to everyone who attended today. We hope you all got something out of it, and the recording of today's presentation will be available in around 24 hours. All right, have a great rest of your day.